Hello students, let's discuss few numericals from lesson Thermodynamics. Question number 4. A gas contained in a cylinder fitted with a frictionless piston expand against a constant external pressure of 1 atmosphere from a volume of 5 liters to a volume of 10 liters. In doing so, it absorbs 400 joule of thermal energy from its surrounding. Determine the change in internal energy of system. So, here we can see in this particular question, it is given pressure of 1 atmosphere. It means pressure is given. Then from a volume of 5 liter to a volume of 10 liters. So volume is changing. So let's write it as a 1 as a V1 and next volume as a V2. In doing so, it absorbs 400 joule of thermal energy. It means Q is given, which is 400 joule. Now determine the change in internal energy of system. So here we need to find out internal energy. We indicate internal energy symbol by U. So change in internal energy is given. It means del U we need to find out. So let's write all given data. P is given. Which is 1 atmosphere. Let's convert that 1 atmosphere into Pascal, and standard value is 1.013 into 10 raised to 5 Pascal. Then V1 is given, which is 5 liter. This also again we need to convert. So liter to meter cube. We need to multiply it with 10 raised to minus 3. Then similar way for V2. $10 liter. So 10 into 10 raised to minus 3. Then Q is given, that is 400 joule. Now we need to find out del U. So first we'll find out work done, because according to first law of thermodynamics, del U is equal to change in internal energy is equal to heat minus work done. Now we are having this Q value here. First we need to find out work done, then we can find out change in internal energy. For work done by the system on its surrounding, formula we are having, that is work done is equal to P into del V, which is nothing but P. I can write it as a V2 minus V1. Now let's put all values. Work done is equal to pressure is 1.013 into 10 raised to minus 3. Then V2 value is given, that is 10 liter, and liter to meter it is 10 into 10 raised to minus 3. So 10 minus 5, 10 raised to minus 3. I'll write it as a common, that is 10 raised to minus 3 here. Then as you can see, this is just simple multiplication. 10 minus 5 is 5. So 5 into 1.013 into here, this should be 10 raised to 5. So I'll just rewrite this thing, 10 raised to plus 5. So 5 into 1.03 into 10 raised to 5 into 10 raised to minus 3. So 10 raised to 5 into 10 raised to minus 3, that is 10 raised to 2. Now, as you can see, this is simple multiplication. 5 into 1.013. When we'll multiply, we'll get answer 5.065 into 10 raised to 2 joule. So this is work done which we have got. Now by using this, we'll find out internal energy Q minus W, which is equal to, now Q is given, that is 400. So 400 minus, now this is 5.065 into 10 raised to 2. So that is 506.5. So that will subtract 506.5. So final answer. Again, this is simple subtraction which will give us 106.5 joule. Now here answer which you are getting, this answer is in negative. So this negative sign is indicating here there is a decrease in internal energy. Okay, so this is our final answer and negative sign is decrease in internal energy. Now let's move to next question. That is question number 5. A system releases 125 kilojoule of heat while a 104 kilojoule of work is done on the system. Calculate the change in internal energy. Now we can see here in this particular question, it is mentioned releases 125 kilojoule of heat, right? So we'll write in data, first thing is given, that is heat 125 kilojoule. So let's write Q is equal to, as here it is given releases, that is why we will put negative sign. So 125 as system is releasing, that is why minus 125 kilojoule of heat. Then again, while 104 kilojoule of work is done on the system, here as it is mentioned work is done on the system, that is why we'll write W is equal to minus 104 kilojoule. Now here it is given calculate the change in internal energy. It means we need to find out del U value. Del is change, U is internal energy. So del U is equal to question mark. According to first law of thermodynamics, change in internal energy is equal to Q minus W. So minus 125 kilojoule minus 104 kilojoule. So after substituting all values, now this is again minus 125, minus minus will become plus. It means minus 125 plus 104. So which will gives us minus 21 kilojoule. Again here you can see internal energy which we are getting, it is in a negative. So this negative is indicating here there is a decrease in internal energy. So suppose if you are getting positive answer, what it will indicate? It will indicate there is a increase in internal energy. So negative sign here, it is indicating decrease in, for this particular answer there is a decrease in internal energy. Now let's move to next question, which is question number 6. Efficiency of Carnot cycle is 75%. If temperature of the hot reservoir is 727 degrees Celsius, calculate the temperature of the cold reservoir. Now, here in this question, efficiency of a Carnot cycle is given, which is 75%. So for efficiency, we are having symbol eta. So eta is 75%. 75% means I can write 75 upon 100, which is nothing but 0.75. Now, in data, if temperature of the hot reservoir is 727, so for a temperature of hot reservoir, we indicate that with symbol TH. So TH is equal to 727, but this is in a degree Celsius, and if you want to convert in Kelvin, we need to add. So we need to add 273 so that we can convert it into degree Kelvin. So when we are after adding, we'll get answer in Kelvin. Then for efficiency, now calculate the temperature of the cold reservoir. It means TC we need to find out. Then for efficiency, we are having formula eta is equal to 1 minus TC upon TH. So I'll just rearrange this so that I can get this thing in format of TC is equal to. So I'll just rearrange this. So TC upon TH is equal to 1 minus eta, then TC is equal to TH into 1 minus eta. TH is 1000 and 1 minus eta, efficiency, which is 0.75. So 0.75. So 1000 into 1 minus 0.75. Again 1 minus 0.75 is 0.25, and 0.25 into 1000. So 1000 into 0.25, which is 250. This is temperature. So our answer is in Kelvin. Now we can convert this into degree Celsius. So for that we need 273. Then we can convert it into degree Celsius also. So TC is equal to 250 minus 273. So final answer which will get in degree Celsius. So this is temperature of cold reservoir, which is 23 degrees Celsius. Now let's move to next question, which is question number 6. Question number 6. A Carnot refrigerator operates between 250 Kelvin and 300 Kelvin. Calculate its coefficient of performance. Now, let's discuss what is given here. A Carnot refrigerator operates between 250 Kelvin and 300 Kelvin. It means two different temperatures are given, and here we need to find out coefficient of performance. For coefficient of performance, we indicate with symbol K. So K is equal to question mark. Then here two different temperatures are given. So let's write data. Tc is equal to 250 Kelvin and Th is equal to 300 Kelvin. For a coefficient of performance formula, K is equal to Tc upon Th minus Tc, that is 250 upon 300 minus 250. So after substitution, 250 upon 300 minus 250 is 50. So answer is 5. So as two temperature given, and here for coefficient of performance we are having Tc upon Th minus Tc formula. Just by simple this substitution and solving, we are getting this final answer, and this is nothing but 5. Now let's move to next question, that is question number 8. An ideal gas is taken through an isothermal process. If it does 2000 joule of work on its environment, how much heat is added to it? This is theoretical question. Now, here in this question, if it does work 2000 joule of work on its environment, it means work is given, which is 2000 joule. But here it is given that an ideal gas is taken through an isothermal process. So when isothermal process is there, in that case, so let's write for isothermal process. For a isothermal process, change in internal energy is 0. So if you are knowing this thing, then you can solve this theoretical question easily. So for isothermal process, there is no change in internal energy. So change in internal energy is 0. And according to first law of thermodynamics, del U is equal to Q minus W. And here, how much heat is added to it, it is mentioned. So how much heat is added to it means Q is equal to question mark. So Q is equal to question mark. And according to first law of thermodynamics, so Q is equal to del U plus W. But there is no change in internal energy. So 0 plus. And given is work done, that is 2000 joule. So our answer is Q is equal to 2000 joule. So we need to add 2000 joule, then there will be no change in internal energy, right? So this much work need to be added. So this is our final answer for this particular question. So very few formulas are there in this particular lesson. Now next time, next sums we'll be discussing. Thank you.